We are from D1 and D8. We present the answer of Modul Chempower set 6 in the topic of alkanes. Question 1 is, draw the structure of 1,5-dimethyl cyclobutene. Explain why the given name is correct according to Isaac nomenclature. Thus give the correct name. Firstly, we need to draw 1,5-dimethyl cyclobutene and it will become like this. Explain why the given name is incorrect. Why? Because the substituent is not numbering in the lowest number. As you can see, if we number the substituent from clockwise, we will get 1, 2, 3, 4, 5. Meanwhile, if we number the substituent anti-clockwise, we will get 1, 2. So, which one is the lowest? Of course, using anti-clockwise, it is 1, 2 is the lowest. So, the correct name is 1,2-dimethyl cyclobutene. Question 1b. CH3, CH2, CH3, and CH3, CH2, 6CH3 are the compounds which belong to the same homologous series. Question B1. Which compound has the higher volume bond? And explain. As you can see, the first compound is butane, and the second compound is octane. How to know which one has the higher volume bond? We need to remember 3 steps, which is when the molar mass is increasing, van der Waals force also will increase. Thus, the volume bond will increase. So, from the question, octane or butane has the higher volume bond? The answer is octane. So, in the exam, you may answer like this. Octane have higher volume bond than butane because octane have a bigger molar mass and stronger van der Waals force compared to butane. Question B2. Both compounds is soluble in organic solvent. Explain. First thing, we should know that alkanes is almost insoluble in water, but alkanes is soluble in organic solvents. What is organic solvent? We also known as non-polar solvent. As example is benzene, chloroform, or other hydrocarbons. So for this question, we may answer alkane is soluble in organic solvent because alkane is non-polar molecule, while organic solvent is non-polar solvent. So alkane can form intermolecular van der Waals forces with organic solvent. Question 2a. Give the two main product forms when an alkane is present in the plentiful supply of air. The keyword you must know here is plentiful supply of air. Air is equal to oxygen, so we know that alkane undergoes complete combustion. When it undergoes complete combustion, it will give us carbon dioxide CO2 and water H2O. Question B1. As produced when hydrocarbon Y react with reagent Z when exposed to sunlight, identify X and Z. From this question, we know that this is reaction of halogenation. The type of reaction is free radical substitution reaction. The name halogenation because it includes Er, which is our halogen. So, we want to identify X and Z. It was given X is C2H5Br. So, we will write it as CH3, CH2Br. Meanwhile, our reagent Z is Br2. Question B2. Write the complete chemical equation for the reaction B1. From question 1, we know that when Y reacts with Z, we will produce X. So, our Y CH3 will react with reagent Z Br2 and produce X, which is CH3, CH2Br, and we must add HBr because if we doesn't add HBr, our chemical equation is not balanced. And so, don't forget to write UV or HV or sunlight in your chemical equation because if there's no sunlight, alkane doesn't hold any reaction. Question B3. Write the chemical equation to show the formation of free radical of bromine in initiation step. We have learned the reaction mechanism of alkane. Initiation step is the first step to create the free radical halogen. Homolytic DuPont cleavage create the free radical. When we write the mechanism, don't forget to draw the half-headed arrow. We use half-headed arrow to show one electron being moved to one bromine, another one electron also being moved to another bromine. So it will create two free radical bromine. Question B4. Draw the new alkane product form in the termination step. Termination step is the last or third step in reaction mechanism of alkane halogenation. We know in termination step we have 3 products. First product is halogen that is formed when free radical halogen combined with another free radical halogen. Second product is alkane. This is when free radical alkane combined with another free radical alkane. And the third product, which is our major product, is haloalkane, which is formed when free radical alkane combined with free radical halogen. From this question, it asks us new alkane product. So, we will choose which one? Of course, we will choose the second one, which is alkane. The question is asked to draw the new alkane product. So it will become like this. Free radical alkane plus free radical alkane will combine and form the new alkane, or we can name it as butane. Alright, that is our last question. So, thank you for watching. Hope to see you all again, and I hope we will success in PHP and together. Thank you.